Good evening, children.
Good evening.
Good evening, ma'am. Good evening, ma'am.
Good evening. Children, get your NCRT textbook because I'm not going to write the question. I'll read the question and we'll work the answer. We'll solve the answer. Sorry, we'll work the question. Please get your NCRT maths textbook. All right, children. Please write down this. I'll explain. Am I audible, children?
Yes, ma'am. Yes, ma'am.
Yes, children. So this exercise 8, very good. 13.8, question number 4. I've not written the question. Please refer your book for the question. Take down the solution. I'll explain. Done, children?
Complete.
Yeah. All right. Now, if we have to find out, supposing the total number of students in a class is 30. Total number of students in a class is 30. And number of boys is equal to 10. So of course, number of girls is equal to 20. Now, if we have to find the fraction of the boys to the class, or as it is given here, 1 minute, what fraction of the class are boys? Okay. What, if you have to answer this question, what fraction of the class, what fraction of the class are boys? Okay, so what fraction of the class are boys? So we know without working, we know 1/3 of the class are boys, because 10 by 30, 1 by 3. What fraction of the class are boys? 1/3 of the class are boys, and 2/3, 2 by 3, because 20 by 30. 2/3 of the class are girls. Correct, children? What fraction of the class are boys?
1 by 3.
1/3. 1/3 of the class are boys. What fraction of the class are girls?
2/3.
2/3. 2/3 of the class are girls. So how did you find that answer? 1 by 3. How did you get 1 by 3? Number of boys by the total number of students, by the total. So if the question is what fraction of the class are boys, this will come in the numerator and this will come in the denominator. What fraction of the class are boys? Are boys. So boys will come in the numerator and the class will come in the denominator. Class will come in the denominator. Similarly, what fraction of the volume of the earth is the volume of the moon? Is the volume of the moon is the question. What fraction of the volume of the earth is the volume of the moon? So this will be the numerator. Volume of the moon will be the numerator. Volume of the earth will be the denominator, like boys here and class or students here. So volume of the moon by the volume of the earth is the required ratio. So now it's given that in the question, it's given that the diameter of the moon is approximately 1/4 of the diameter of the earth. This is given to us. Now, diameter is twice the radius. So since the moon is smaller in size when compared to the earth, we'll take the radius of the moon as smaller and the radius of the earth as capital R. Or you can even take R1, R2. I'm taking small r as the radius of the moon, capital R as the radius of the earth, because the moon is smaller in size when compared to the earth. Okay, so diameter is twice the radius. So this is diameter, twice the radius meaning diameter. So diameter of the moon is 2r, is 1/4 of the diameter of the earth. The radius of the earth is capital R, so diameter is 2r. So we have converted this one to an equation using the variables r and r. So diameter of the moon is twice smaller is equal to 1/4 into diameter of the earth. It is twice capital R. Now just simplify. So 2 1s are 2 2s are. Okay, so on cross multiplying, you get 2 2s are 4. 4r is equal to what do you have here? R. So R is equal to 4r, which means the radius of the earth is approximately 4 times the radius of the moon. The radius of the earth is approximately 4 times the radius of the moon. So we've got a relation now. Now let's find volume of moon by volume of earth. This is what we are supposed to find. Volume of earth, sorry, moon by volume of earth. So both are spherical. So 4 by 3 pi small r cubed by 4 by 3 pi capital R cubed. So 4 by 3 and pi gets cancelled in the numerator and denominator. Now r cubed by r cubed can be written as r by r the whole cubed. Okay, and r by we know that capital R is equal to 4 times small r. Capital R is 4 times small r. All right. So instead of capital R, 4 times small r the whole cube. R and R gets cancelled. So you have 1 by 4 the whole cube, which is 1 by 64 or 1 is to 64. So the required ratio is 1 is to 64. Understood, children?
Yes, ma'am.
Yes.
Yes, ma'am.
Yeah. Anybody is still to write, or can I clear the screen?
No, ma'am. Completed.
Okay. Yeah, next one is the same exercise, question number 6. Same exercise, question number 6. I'm not working this fully, but I'll just tell you how to do it. A hemispherical tank is made up of iron sheet 1 centimeter thick. So W is equal to 1 centimeter. If the inner radius is 1 meter, that is small r is 1 meter or 100 centimeter, then find the volume of iron used to make the tank. So the wall of the hemispherical tank is thick. The tank is a hemispherical tank. The wall of the hemispherical tank is thick. How thick is the wall? It is 1 centimeter thick. What is the inner radius? 100 centimeters. So the outer radius will be the inner radius plus the thickness. So 100 plus 1. See, they must be in the same unit. It's not 1 plus 1 because this is 1 meter. This is 1 centimeter. So you cannot add this. So 100 centimeter plus 1 centimeter, 101 centimeter. Now we have to find the volume of iron in the tank. Volume of iron is equal to external volume minus internal volume. External volume minus internal volume, which is 4 by 3 pi. Oh, not 4 by 3. I'm so sorry. This is a hemispherical tank. So 2 by 3. So 2 by 3 pi capital R cubed is the external volume minus 2 by 3 pi small r cubed is the internal volume. So 2 by 3 pi is common. So r cubed minus r cubed. You'll have to substitute the values and find the volume. So I leave it here, children. You will have to continue, meaning 22 by 3 into 22 by 7 into 101 cubed minus 100 cubed. And the answer will be in centimeter cube. You can convert it to meter cubed. If you want, you can convert that to meter cube. Yeah, children, take down. Done, children? Yeah, finish writing, children. Don't complete the answer now. No, I want you to respond. Please tell me, have you finished writing?
Yes, ma'am.
Yes, ma'am.
All right. Yeah, next is the 8th one. A dome of a building is in the form of a hemisphere. From inside, it was whitewashed at the cost of rupees 498.96. If the cost of whitewashing is rupees 2 per meter square, find the inner surface area of the dome, volume of the air in the dome. Okay. So a dome of a building is in the form of a hemisphere. From inside, it was whitewashed. From inside, it was whitewashed. So the dome is a hemisphere. So from inside also, it will be a hemisphere. The dome, you can see the outer part, you can see it outside the building. When you're inside the building, you can see the cup-like thing of the hemisphere. So what is given? Rate and cost is given to you. So rate of whitewashing or the inner CSA, because you're whitewashing the inner CSA of the hemisphere. You're whitewashing the inner CSA of the hemisphere. So inner CSA into rate of whitewashing, is equal to the total cost of whitewashing, is equal to the total cost of whitewashing. I'll just write WW, whitewashing. The inner CSA, why inner CSA? Why not volume or something else? Because where is the work done? Where are we whitewashing? We are whitewashing the inner CSA. We are whitewashing the inner CSA. So inner CSA into the rate is the total cost. So inner CSA, we do not know. Inner CSA, we do not know. So inner CSA is into, what is the rate given? 2 rupees per meter square. 2 rupees per meter square is equal to the total cost. What's the total cost? Rupees 498.96. So the inner CSA will be 498.96 divided by 2 meter square. Because here it is 2 rupees per meter square, no? So the answer will be in meter square. Inner CSA will be in meter square. So what's the formula to find the inner CSA? 2 pi. What's the formula? Inner CSA 2 pi.
R square.
R square. Okay, so 249.48 meter square. So now take the values 2 into 22 by 7 into R square. We do not know R. We don't know. We'll have to find R. R square is equal to, you can take this as a fraction, 24948 divided by 100. You can get rid of the decimal point. I'm not converting. We're just getting rid of the decimal point. So next step. So R square is equal to 24948 by 100 into 7 by 2 into 22 after transposing. All right, so now we'll have to cancel. 25 times. No, I'll just write it a little below. I don't have space to cancel, so I'll just write it a little below. R square is equal to 24948 by 100. Actually, you can simplify here itself if you want. 4 how many times? 4 6 are 24, 4 2s are 8, 4 3s are 12, 4 7s are 28, and this will be 425 times. So R square is equal to 6237 by 25, 6237 divided by 25 into 7, and in the denominator you will get 2 into 22. So whenever we have 22 in the denominator, this number must mostly be divisible by 11 or 22. This number should mostly be divisible by 11 or sometimes even 22. We'll try 11 first. All right. So 11 2s are 11 5s are 55. 7 is a remainder. So 6 are 66. 7 is a remainder. 7 are 77. So it is divisible. So 567 into 7. All right. So R square is equal to, find the prime factors of 567. 567. You should not multiply. See here, R square is this one. So don't multiply. Do not multiply. Find the prime factors. So 3. 3 ones are 3 8s are 24. 3 9s are 27. 3 6 are 18. 3 3 21. 3 7 7 ones. So r square is because we're not able to simplify further. We are not able to simplify further. So r square is equal to 3 into 3 into 3 into 3 into 7 divided into 7. There's already a 7 in the numerator, divided by 25 can be written as 5 into 5. 25 can be written as 5 into 5 because r square, no? So 5 into 5 into 2 into 2. So this is what you have. This is what you have. Do not multiply. Do not multiply 577 and 7. Please find the prime factors of 567. So like this we have. So r will be equal to, you cannot cancel anything. Okay, so r is equal to, from 4 threes, 2 threes will come out. From 4 threes, 2 threes will come out. From 2 sevens, 1 7. From 2 fives, 1 5. From 2 twos, 1 2. So r is equal to 3 threes are 9, 9 sevens are 63 by 10 or 6.3. 6.3 what? Meter. 6.3 meters. Because here it's all in meters, meter square. So first we had to find the inner CSA that we found here, 249.48. The first question is to find the inner surface area of the dome. The inner surface area of the dome is this one, 249.48. The inner surface area of the dome is 249.48. Here we have found. Maybe here you can write inner surface area. Inner surface area is equal to 249.48 meters square. Then we proceed to find the radius. And the radius is 66.3 meters. Now you'll have to find the volume. That you can do it by yourself. Volume of the air in the dome. Volume of the air in the dome is equal to, volume of air is equal to 2 by 3 pi r cubed. Substitute the value of r and find the volume. The answer will be meter cube. Take down, children. Done this slide, children?
Yes, ma'am.
Yeah. Well, whenever you're solving, whenever the equation is like r square is equal to or r cubed is equal to, you should not multiply. For the bigger numbers, you should find their prime factors. So then if it is r square, from 2 equal primes, you will bring 1 out. If it is r cubed, then from 3 equal primes, you will bring 1 out. Yeah, 2 by 3 pi r cubed you can solve later. Finished till r is equal to 6.3.
Yes, ma'am.
All of you writing?
Completed, ma'am.
Yeah.
Completed, ma'am.
Okay.
Completed.
Very good. So I'll tell you again. Inner CSA into the rate is the total cost of whitewashing. Inner CSA, because we do not know the value of R, so we'll write it as it is. Rate is 2 rupees per meter square, and this is the total cost. So the inner CSA will be this one divided by 2. And we get 249.48 meters square. This is the inner CSA. So now we have to work ahead with this equation to find the value of R. So 2 into 22 by 7 into R square is equal to, here we're shifting the decimal point by 2 places. So we divide by 100. Then on transposing and simplifying, this is what we get. 567, we are not going to multiply these two. Instead, we'll find the prime factors of 567. So at the numerator and denominator, you can see only prime factors. So then you know R square is this. So R will be 4 3s, 2 3s, 2 7s, 1 7, 2 5s, 1 5, 2 2s, and 1 2. 63 by 10, which is 6.3. The second part is to find the volume of air in the dome. 2 by 3 pi r cubed. Okay, the next is the ninth one. "27 solid iron spheres, not hemispheres, spheres. 27 solid iron spheres, each of radius r and surface area s, are melted to form a sphere with surface area s dash. Find the radius r dash of the new sphere." So there are 27 identical small spheres. There are 27 identical small spheres, each of radius small r and each with surface area small s. Now all these are melted, all the 27 are melted, and they are made into one big sphere of radius r dash and surface area s dash. We need to find the radius r dash of the new sphere. Is it understood, children? What is given in the question? How many small spheres are there?
27.
27.
27.
What is the radius? What is the radius of each small sphere?
R.
R.
R. What is the surface area of each small sphere?
Capital.
S. And this is melted. All the 27, they are melted and recast into one big sphere. One big sphere. What is the radius? R dash. What's the surface area?
S
S dash.
S dash. We need to find R dash. We need to find the radius R dash of the new sphere. See, you will not get a number because there is no number involved here. You will not get a number. You will only get R dash in terms of R. That's all you can do. You can only find R dash in terms of R. You cannot get it's 5 centimeters, 6 centimeters. That you cannot get. So small sphere, radius R, surface area S. Big sphere, radius R dash, surface area S dash. They're spheres, not hemispheres, spheres. 27 small spheres, all are melted and recast into one big sphere. All right. So volume of all the, or you can write the volume of the big sphere first. Anything first. Volume of the big sphere or the new sphere. volume of the new sphere. Volume of the new sphere is equal to volume of all the 27 small spheres. Is this correct? Is this equation correct? You should only write this. If you can write this, you can get full marks. Meaning, with this, you can work very easily. Is this equation correct? Yes, class? Yeah. So volume of the new sphere is equal to volume of all the 27 small spheres. What's the volume of the new sphere? 4 by 3 pi r dash cubed is equal to the volume of all the 27 small spheres, 27 into each one, 4 by 3 pi r cubed. Is this correct?
Yes,
Yes,
please.
ma'am.
Yeah. Volume of one small sphere is 4 by 3 pi small r cubed. All the 27 into 27. Now on either side, 4 by 3 gets cancelled. Pi and pi gets cancelled. And we are left with r dash cubed is equal to 27 r cubed. So r dash is equal to the cube root of 27 r cubed. So r dash is equal to 3r. Is this understood, children?
Yes, ma'am.
Yes, ma'am.
Or if you want, you can also write this one as 3r into 3r into 3r. Anything. What is 27r cubed? 3r into 3r into 3r. So from there are 3r, there is 3r 3 times. So 1 will come out. So the radius r dash of the new sphere is 3 times the radius of each small sphere. 3r. So supposing the radius of the small sphere, the radius of the small sphere is say 3 centimeters. Then the radius of the new sphere formed will be 9 centimeters. Okay, so we have answered the first part of the question. Find the radius r dash of the new sphere. We have answered that. Next, take down this, children. Please take down this.
Completed, ma'am.
All right, children. Yeah. So next we have to find the ratio, or we need to the ratio of S and S dash. So S is the surface area of each small sphere, and S dash is the surface area of the big sphere or the new sphere. We need to find S by S dash. That is the ratio of the surface area of each small sphere to the surface area of the big sphere or the new sphere. So sphere, we know the surface area is 4 pi r square. So 4 pi r square divided by 4 pi r dash square. Am I right, children?
Yes, ma'am.
Yeah. 4 cancels. Pi cancels. So r square by r dash square can be written as r by r dash the whole square. So r is r. R dash is 3r. Substitute that. The whole square. So r gets cancelled. 1 by 3, the whole square is 1 by 9. So the ratio S to S dash is 1 by 9 or 1 is to 9. Please write down, children.
Completed, ma'am.
Yeah.
Completed, ma'am.
Yeah. Any questions, children, here?
No.
No, ma'am.
Oh, okay. Then over to exercise 13.7. All right. So when a right triangle is rotated about one of its legs, the legs here in this right triangle, the legs are 12 centimeters and 5 centimeters. AB and BC are the legs of length 12 centimeter and 5 centimeter respectively. So when the right triangle is turned about one of its legs, the solid generated is a right circular cone. The solid generated is a right circular cone. Right circular cone. Whenever a right triangle, a right angled triangle is rotated about the legs, either AB or BC. Here AB and BC are the legs. So if this right triangle is turned about AB or about BC, now here it's turned about AB, then the solid generated is a right circular cone. A cone is not formed. It will trace the shape of a cone. When you turn the right triangle about the side 12 centimeters, it will trace the shape of a cone, right circular cone of height. Since you're turning it about the side 12 centimeters, the height of the cone also will be 12 centimeters. Since you're turning it about the side or about the leg 12 centimeters, the height of the cone generated will be 12 centimeters. The other leg will become the radius. The other leg, that is BC, 5 centimeters, will be the radius of the cone. And the hypotenuse will be the slant height of the cone. Now, supposing you turn the right triangle around about the side BC, then BC will be the height of the cone. And 12 centimeters will be the radius of the cone. Whichever side, whichever leg, about whichever leg you're turning, that leg will become the height. The other leg will become the radius. The hypotenuse will be the slant height. Right triangle, 2 legs, hypotenuse. Right triangle, you're turning it about 1 leg, say 12 centimeters. When you do that, the solid generated is a cone, right circular cone. If you turn it about the side 12 centimeters, that itself will become the height of the cone, 12 centimeters. The other leg, that is BC5, that will become the radius of the cone. And the hypotenuse, AC, 13 centimeters, is the slant height of the cone. Now we have to find the volume of the cone generated. 1 by 3 pi r square. Go ahead, substitute the values. You can find the decimal value. I just left it like that. This is the volume of the cone generated. Now, supposing you'll have to find the, now you can rotate the right triangle about AB or about BC. So 2 different right circular cones will be generated. Supposing you turn the right triangle ABC about the leg 12 centimeters. A right circular cone is generated. But if you turn it about the leg 5 centimeters, a different right circular cone is generated. That means the radius and height will be different. The slant height will be 13 for both. The slant height will be 13 for both, but the radius and height will be different. So when the right triangle ABC is turned about the leg 5 centimeters. Here we've written for 12, okay? When the right triangle ABC is turned about the leg 5 centimeters, the solid generated is a right circular cone of height 5 centimeters and radius 12 centimeters and slant height 12. Okay, now we'll have to, supposing you'll have to compare the volumes. Don't find the volumes separately. Every time you have to compare two things, do not find their volumes separately. Do it in the ratio itself. I've told you this many times earlier. If you have to find the volume of both the cones, then find the volume of both the cones. If they're not asking you to find the volume, they only want the ratio. Find the ratio straight away. Don't find the volume and then find the ratio. Find the ratio of the volume straight away. So if that is a question, then volume 1 by volume 2 is equal to 1 by 3 pi r, we'll call it r1 square h1 by 1 by 3 pi r2 square h2. So 1 by 3 and pi gets cancelled. So in the first case, what is the radius? 5. Height is 12. 5 and 12. In the second case, the radius is 12. And the height is 5. R square h. 12 and 12 cancels. 5 and 5 cancels. So the required ratio is 5:12. Take down, children. Done the slide, children?
Yes, ma'am.
Okay. We have answered question number 7 and 8 together. If you have to find the volume of the cone separately, find it separately. If you have to find the ratio, find the ratio straight away. Don't find the volume. Done writing, children?
Yes, ma'am.
Yes, ma'am.
Very good. Okay, now let's just check if we understood. So you all know how to find the hypotenuse, so I'll write that also. Now tell me, the two cases are when the right triangle is turned about the leg AB, then when the right triangle is turned about the leg BC. These are the two cases. So when it's turned about the leg AB, what is the radius? What is the height? What's the slant height? When it's turned about the leg BC, what is the radius? What is the height? What is the slant height? Yes, children. Complete. What is R1, H1, L1? What is R2, H2, L2?
Ma'am, R1 is 10.
R1 is, no, okay, 1 minute. Thank you. But leg AB, no? So what will AB become for the cone?
Height, ma'am.
Height. So this is 24, correct?
Yes, ma'am.
Yes, ma'am.
So the other leg will become the
Radius.
radius. And which is the slant height?
26, ma'am.
26.
Hypotenuse. Very good. And here it's turned about the side BC. So BC will become the
Height, ma'am.
height. So then the other leg, which is the other leg?
AB, ma'am.
AB. So that will become the radius. And the slant height is?
26.
Yeah.
26.
Yeah. So what I'm trying to say is, if they ask you to find the volume of this one or this one, find the volume using the formula 1/3 pi. So R square H. If it is about only one cone, then you don't have to say R1, H1, L1. You can just say RHL. Here, since we are discussing about both, I wrote R1, H1, L1. If it's only about this, you don't have to take R1, H1, L1. You can just say pi R square H. So if they're asking you to find the volume of this one, just find the volume 1/3 pi R square H. But supposing they want you to find supposing the question is to find only the ratio. They're not asking you to find the volume. They're not asking you to find the volume. They only want the ratio of the volumes. They don't want V1 and V2. They don't want volume. They want the ratio of the volume. In that case, find the ratio straight away. Don't find the volumes. 1/3 pi R1 square H1 by 1/3 pi R2 square H2. Directly like this, you should find the ratio. 1/3 cancels, pi cancels. So R1 square, so 10 into 10 into H1, 24, divided by R2 square, 24 into 24, into H2, 10. So 24 cancels, 10 cancels, and then here 2 5s are, 2 12s are. So the required ratio is 5:12. You all get my point, what I'm trying to say?
Yes, ma'am.
All right. Next is example 16. Example 16. Monica has a piece of canvas whose area is 551 meters square. Okay. Monica has a piece of canvas. It's a material. Canvas is a material. And the area of the cloth. So the cloth is rectangular. The cloth is rectangular. You will not get a conical cloth in the market. The cloth is rectangular. The cloth has length and breadth. Okay. So Monica has a piece of canvas. It's a rectangular piece. It's not given, but we know that material in the market is available only in a rectangular, as a rectangular piece. So Monica has a piece of canvas whose area is 551 meters square. Okay. She uses it to have a conical tent made. Okay. So she makes a conical tent out of it with a base radius 7 meters. So the base radius is fixed to 7 meters. Assuming that all the stitching margins and the wastage incurred while cutting amounts to approximately 1 meter square, find the volume of the tent that can be made with it. Okay. So now how much she has? 551 meters square. Now, is all the 551 meters square used up to make the cone? No. 1 meter square is wasted. So how much is actually present in the tent? Only 550 meters square. The total area of the cloth she has is 551. But all this 551 is not in the tent now. All this area of 551 meters square is not in the tent, because while making the tent, 1 meter square of cloth was wasted. So -1. So 550, this area of the cloth is now in the tent. This area of cloth is in the tent now. This is the area of the cloth in the tent. And in the tent, where is the cloth used? To make the CSA. The canvas is not used on the floor. Canvas, while putting up a tent, canvas is not used on the floor. They'll only put up the CSA of the tent with the canvas. The floor, maybe you can spread a mat or a carpet later, but the canvas is not cut in a circular form and spread like this. It's not used. If nothing is mentioned, it is not used. If the canvas is used on the floor, it will be given to you explicitly. If nothing is mentioned, it is assumed or understood that the canvas is not used on the floor. Then where is the canvas? It is only in the CSA of the tent. See, the conical tent has two portions. One is the curved surface area and the other is the floor area. There are two areas. One is the curved surface area. The other is the floor area. These two make the total area of the canvas. No, but the canvas is not used on the floor. Then where is the canvas? It's only in the CSA. How much of the canvas is in the CSA? Not 551, because 1 meter square is wasted. So 550. So the CSA, the curved surface area of the tent, is equal to 550 meters square. This is the equation. This is the equation. So in example 16, conical tent. It's a conical tent. Okay. So CSA of the tent is equal to 550 minus 1, 551 minus 1. Which is 550 meters squared. This is the CSA of the tent. CSA of the tent is 550 meters squared. CSA means pi RL. Pi RL is equal to 550. What is the value of pi? Nothing is mentioned, so you can take 22 by 7. Into radius is given 7 in the question. It's given into L is equal to 550. So 7 gets cancelled. L is equal to 550 divided by 22. L is equal to tables of 11, or you can do 22 straight away. 22 ones are 22, 22 twos are 44, 11 is the remainder, 5s are 110. So L is equal to 25 meters. Now the question is to find the volume of the tent. And we know to find the volume, the formula is 1 by 3 pi r square h. Volume of the tent is equal to 1 by 3 pi r square h, for which you need r and h, but we don't have the value of h. So you should find h. We know that r square plus, r square plus h square is equal to L square. So r square is 7 square plus h we don't know is equal to 25 square. So h square is equal to 625 minus 49. H square is equal to 576. H is equal to 24 meter. So 1 by 3 into 22 by 7 into 7 square into h, which is 24. into 7 into 7 into 24. Yeah, write down, children. Done, children? Finish writing?
One minute, ma'am.
All right, all right. No hurry, yeah. Do it.
Completed, ma'am.
Yeah. Okay, so how much canvas does Monica have? What's the area of the canvas with Monica? What is the area of the canvas with Monica?
550.
Wrong. How much cloth does Monica have? She has 551 meters. 551. Monica has 551 meters square of canvas. Now, when she tries to make a tent, a conical tent, 1 meter square is wasted. So the amount of cloth present in the curved surface area of the tent is 551 minus 1, 550. Why we are saying curved surface area? Why not volume? Because where is the cloth? Where is the canvas? It is used to build the curved surface area of the tent. The canvas material is used to build or is used to make the CSA of the tent. The canvas material is not used on the floor. So it's used to make the CSA. So CSA is 550. When you work that, you can find the value of L. And then using R and L, find H. And then find the volume of the tent. Yeah, exercise 13.6. Question number 7. A lead pencil. So if you all can think of that old, Natraj pencil, which has that black and red stripes. Okay, so if you can imagine that the top of the circle, the top of the cylindrical pencil is circular. The top of the cylindrical pencil is circular. So you can see that there is the circular portion of the lead here. Okay, and this is wood. This is wood. I'm talking about the top view. When you take a look at the top view of the pencil, the top view is something like this. So you can see the black circle here, which is the lead, and this one is the wood. This one is the wood, and the whole thing is a pencil. Pencil is, when we say pencil, it is the lead and wood together. Lead is only lead. Wood is only wood. Lead and wood put together is the pencil. Lead and wood put together is the pencil. So the pencil is a solid cylinder. Lead is also a solid cylinder, but wood is a hollow cylinder. Because if you remove the lead from the pencil, the remaining is wood. If you remove that cylindrical lead from the pencil, if you remove that, what remains is the wood. And if you see that wood is a hollow cylinder, it has an internal radius and external radius. The height of everything, the height of all the three is the same. The height of the lead, the height of the wood, the height of the pencil, all the same. Okay, so we're writing lead. Don't write now. Lead, wood, and pencil. Lead, wood, and pencil. Now lead. Just imagine that lead in the pencil. It is a cylinder. It's a solid cylinder of radius r and height h. The pencil, the whole thing is the pencil. Wood, lead, both together is the pencil. The pencil is also a solid cylinder of radius r. From the center to this one is the radius of the lead. From the center to this one is the radius of the wood. I'm sorry, pencil. From the center to this one is the radius of the lead. From the same center to this one is the radius of the pencil. Pencil is a solid cylinder. Lead is also a solid cylinder. Height of the pencil, h. Wood is a hollow cylinder because if you remove the lead, if you remove this lead from the pencil, you can see that empty cylinder inside. It's a hollow, so the wood is a hollow cylinder. So it has, because the wall of the wood is thick. The wall of the wood is thick. You have an internal radius and external radius. This is the internal radius. This is the external radius. And the height is the same, h. Do you understand the values, children?
Yes.
Okay. So a lead pencil consists of a cylinder of wood and a solid cylinder of graphite, that is lead, filled in the interior. The diameter of the pencil is 7 mm. The diameter of the pencil.
Excuse
Okay,
me.
so the diameter of the pencil is 7 mm. So that means,
Ma'am,
yeah.
ma'am, in my book, after exercise 13.6, after fourth sum, the next page is completely blank. So I don't have any questions after that, ma'am.
Okay, I'll share the picture on WhatsApp. Just hold.
I'm not having any.
Yeah, I'm sending the picture. Just wait. What about the others?
No, ma'am, we are having.
Okay. Raja, is this chapter completed in school?
No, ma'am, not yet.
Okay. Yeah, I've sent the question. I'm sorry, I've sent that page. Yeah. So the radius of the diameter of the pencil. Diameter, I've just written 2R. You can write D also. But for the pencil, radius is capital R. No, so I've written 2R is equal to 7 mm. Diameter. So R is equal to 7 by 2 mm. And the diameter of the graphite is the lead. Graphite is the lead. The diameter of the graphite is 1 mm. That is 2R is equal to 1 mm. So R is equal to 1 by 2 mm, half a millimeter. The length of the pencil is 14 centimeters. So H is 14 centimeters or it is 140 millimeter. Here also H is 14 centimeter or 140 millimeter. Find the volume of the wood and that of the graphite. You need to find the volume of the wood and graphite. Now, wood inner radius is half millimeter. Outer radius is 7 by 2 millimeter. And the height is 140 millimeter. So we have to find the volume of the graphite and the volume of the wood. Graphite is a solid cylinder. So volume of graphite is equal to pi r square h 22 by 7 into r square 1 by 2 into 1 by 2 into h into 140. So 28 into 5 is what? 5 is the 40, okay, 140, no? Okay. So you can see here 28 into 5. So 7 2s are 14, 2s are 28 and 5. So this will be 110 millimeters square cube. This is the volume of the graphite. Now to find the volume of the wood, you can do two things. To find the volume of the wood, you can do two things. You can find the volume of the pencil, which is again a solid cylinder, pi r square h. So 22 by 7 into 7 by 2 into 7 by 2 into 140. So 5 times 49 into 110. 9 into 110. 5390 millimeter cube. So volume of wood is equal to 5390 minus 110. See, this is one way. Or what you can do is straight away you can find volume of wood. How? Volume of wood is equal to pi r square minus r square into h. So that is 22 by 7 into 1 second. 7 by 2 the whole square minus 1 by 2 the whole square into 140 into 140. So 22 by 7 into a square minus b square is a plus b. 7 by 2 plus 1 by 2, 8 by 2, which is 4, into a minus b. 7 by 2 minus 1 by 2, 6 by 2, which is 3, into 140. So 7 ones are 7, 20 times. This also should give you the same answer, 1280. I'll check. So 22 into 12 into 20. Yeah, 5280. These values you should understand. Volume of the graphite you can find using pi r square h. Volume of wood you can do it in two ways. Either find the volume of the wood straight away using the formula pi r square minus r square to h, or you can find the volume of the pencil And then volume of pencil minus graphite will be the volume of the wood. Anyways, you can do it. Yeah, take down, children. Yes, children, you can ask me if you have any doubts. Done writing? Class use the emoji, raise your hand.
Done, ma'am.
Srijana, Raja, Sindhu, Sanjay, Netra, and Arjun, are you there? Arjun? Understood, children, all of you?
Yes, ma'am.
Got it. Then look at example 14. Example 14. 1 minute. Just have a look at question number 6. Exercise 13.6, question number 6. Write down this one, children. So in this question, children, you're given that the vessel is a closed cylindrical vessel. That's very important. The vessel is a closed cylindrical vessel. The capacity of the vessel is given to be 15.4 liters. So we know we have to convert it to meter cubed. Why? Because when you have to find the radius or height, you know, you will have to find it in meter or centimeter, not in liters. When you have to find the radius and height. I think the height is given. You have to find the radius. The height is 1 meter. So we have to find the radius. Radius you cannot find in liters. Radius we'll find in meter or centimeter, but here in meter because the height is given in meter. You can find it in centimeter also. Then the height will be 100 centimeters. So we have to change liter to meter cubed. So you can use this method. This is the conversion. 1000 liters is 1 meter cubed. 1000 liters is 1 meter cubed. Then 15.4 liters is how many meter cubed? Liter in the numerator, meter cubed in the denominator, or you can write it the other way. Meter cubed in the numerator and liter in the denominator. So on working, we get the capacity of 15.4 liters is nothing but 0.0154 meter cubed. Liter to meter cubed. Now that is the capacity. So pi r square h is equal to, it's a cylindrical vessel. So pi r square h is equal to 0.0154. Height is 1 meter. So on working this, we get r is 7 by 100 or 0.07 meters. The question is to find how many square meters. Let me see the question again. The question says how many square meters of metal sheet would be needed to make it. How many square meters of metal sheet? So how many square meters, meaning meter square, meaning area. What area of metal sheet? What area of the metal sheet is needed? So since it's given, it's a closed cylindrical vessel. It's a closed vessel. It's a closed vessel. That means the material has to be used all over. The material has to be used all over. So we have to find the TSA. 2 pi r into r plus h. So the area of the metal sheet required is equal to 0.4708 meters square. How many square meters of metal sheet? That means you find area, square meters, meaning meter square. So they wanted to find area in meter square. How many square meters, meaning meter square. So they wanted to find the TSA in meter square. Is it fine, children?
Yes, ma'am.
Yes, ma'am.
All right. All of you finished writing this?
Yes, ma'am.
Yes, ma'am.
All right, children. Yeah, now we'll do that example 14. So see, children, supposing, you have a beaker, okay? You have a beaker of juice and the volume of the juice in this is say 3 liters. 3 liters. All right. And now you're serving your guests juice in small glasses, identical glasses. The volume of each glass is 250 ml. You have a container in which the volume of the juice is 3 liters. You're serving your guests in cylindrical glasses and the glasses are identical, having a volume of 250 ml. So then how many glasses can you make? How many people can you serve with 3 liters? Tell me. How much is 1 liter? How much ml is 1 liter?
1000.
1000 ml. So with 1000 ml, how many glasses you can make? Yeah, with 1000 ml, how many glasses can you make?
Ma'am, 4 glasses.
4 glasses. So in 2000 ml, 8 glasses. In 3000 ml, 12 glasses. So it's basically 3 liters by 250 ml, which is 3000 milliliters by 250 milliliters, which is equal to 12. So the number of glasses you can make will be equal to the volume of the juice divided by volume of 1 glass. Volume of 1 glass. Or you can say volume of juice in 1 glass. Because the total volume of the juice is 3 liters. And in every glass, in each glass, the volume is 250 ml. So we divided 3000 ml by 250 ml, 12 glasses. In the same way, in this question, the juice seller, so for this, the answer is 8 glasses. And supposing, not 8, 12 glasses, sorry. 12 glasses. Now, supposing this is a shop. This is a shop and each glass is sold for 30 rupees. It's a shop and each glass of juice is sold for 30 rupees. So how much money is made? 12 into 30. 12 glasses into 30 rupees per glass. 360 rupees. 360 rupees. Yeah. So in example 14, you can write down along with me. Please write down. Example 14. Large cylindrical vessels. Large cylindrical vessel. Radius is 15 centimeters. And the juice is filled up to a height of 32 centimeter. Small cylindrical glass. Radius 3 centimeters. Height 8 centimeters. So number of glasses. Number of glasses is equal to volume of juice in the large So 100 glasses can be made, and the sale proceeds, that is the money the stall keeper makes by selling 100 glasses, is equal to 100 into 3, 300 rupees. Isn't it simple, children?
Yes, ma'am.
Yeah. Is it over, children?
Yes.
Yes, ma'am.
Now it's exercise 13.4, question number 9. So you can see the figure there. Done, children?
Completed, ma'am.
Yeah. So since the figure is given, I think it's easy to understand. The figure is given in the question. Radius of the sphere is r. So the radius of the cylinder also will be r. And the height of the cylinder will be r plus r, 2r. Then the questions are very easy to answer. Surface area of the sphere. Formula is 4 pi r square and radius is r only. So nothing to substitute. That's all, 4 pi r square. Because the value of r is r only. CSA of the cylinder, 2 pi RH. Radius is r, but h is 2r. So only h you will have to substitute. So you get 4 pi r square when you multiply. 2 rows of 4 pi r square. Then we have to find the ratio of the answers we have gotten 1 and 2. 4 pi r square by 4 pi r square, which is 1 by 1 or 1:1. So next class we'll take up the remaining sums, children, in NCERT, from NCERT. I want to do a few more sums from NCERT. So next class on Friday, we'll finish this volumes and surface areas and we'll start circles. We'll start circles. I'll do the numerical part of circles first. That is finding where the figures are given to you and you'll have to find the values of the missing angles. I'll do that part first and then the rest of the chapter. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you, children. Good night. Thank you. Good night.